All right, so today we're going to talk about functions and inverses. The first topic is using the horizontal line test to determine whether the inverse of each function, of each relation, is a function. So first off, horizontal test is similar to what we did last semester, which is the vertical line test. So you're going to draw a horizontal line. And then that line is only allowed to touch the graph once. If it does that, then it passes the horizontal line test. If it doesn't, then if it touches more than once, then it fails the horizontal line test. All right, so if I take any horizontal line and I check how many times that line crosses my graph, that fails the test. Okay, so since this fails the horizontal line test because it touches 3 times, then the inverse is not a function. Okay, so that's the answer to the problem. Problem 2. So I'm going to do the same thing. Find a horizontal line. It should touch a graph, so I'm not going to draw it down here or up here. I'm going to draw it somewhere where it crosses. And I'm going to check how many times it touches my graph. So it only touches once. So this passes the horizontal line test. Okay, so then that tells me that the inverse is a function. Okay. So what is an inverse? An inverse is basically taking the x and y coordinates and switching them. On a graph, it's essentially reflecting it over the line y equals x. So we're going to look at the equation. So for finding the inverse, I'm just going to write some steps off to the side here. So first thing you're going to do is actually switch the x and the y. So first off, in number 3, I don't even see a y. You should remember that this means y equals. Okay, so f of x is the same as y equals. So I'm going to take my x and y, and we're actually going to switch them. So I'm going to put x where I saw y and put y where I saw an x. All right, that's step 1. Step 2 is you're going to solve for the new y. All right, which means I need to get y by itself. So how can I get y by itself? I get rid of my 5 by dividing. So this is x over 5. All right, step 3 is we're going to rewrite it because the notation was f of x. I'm going to change the notation. I'm going to use this notation, and the way you say this is the inverse of f of x. Right, even though it looks like it's f to the negative first, but you just call it the inverse of f of x. I'm going to replace that with y. So really my final answer is the inverse of f of x equals x over 5. Okay, so I'm going to continue to do that for the remaining problems. So first off, this means y equals. Okay, so remember f of x is y equals. I'm going to take my x and y, and we're switching them. So I've got x equals y minus 2. Now I need to solve for the new y. So now I've got x plus 2 equals y, and then I'm just going to rewrite it so that it's using the proper notation. So the inverse of f of x equals x plus 2. And usually you put this on the left side, so that's what, notice that I put it on the left side. All right, so we're going to keep going. This is y equals 8x minus 3. Find your x and y and switch them. Notice everything else stays in the same spot. So x equals 8y minus 3. Then I need to get y by itself. So I have to get rid of the 8 and the 3. I'm going to undo addition and subtraction first. So I do x plus 3 equals 8y. Then I'm going to undo my multiplication by dividing. So I get y equals x plus 3 over 8. And then the last step is, instead of y, I'm going to write inverse of f of x is equal to x plus 3 over 8. All right, problem number 6. Remember, f of x is the same as y equals. Take your x and y, switch locations. So we've got x equals negative 3y plus 6. All right, then I need to solve for y. So to undo addition, I subtract. X minus 6 equals negative 3y. Then I'm going to divide by negative 3. All right, so you can leave it like this. However, sometimes the book will write it as negative 1/3 x, and negative 6 divided by negative 3 is plus 2. So this is one way to write your answer. You could have also said x minus 6 over negative 3, and that's not necessarily wrong. So either of these are equivalent, even though they look different. All right, and then I'm going to do inverse of f of x is equal to negative 1/3 x plus 2, or inverse of f of x equals x minus 6 over negative 3. All right, so technically you could have either of these answers. Sorry. Although this one is probably what you would see on the multiple choice. All right, so number 7, 2 problems left. We got y equals 2x plus 1 over 3. So you take your x and y, you're going to switch them. We got x equals 2y plus 1 over 3. So I'm going to undo this divide by 3 first to get my y by itself. If I multiply it by 3 on both sides, I get 3x equals 2y plus 1. Now I'm going to subtract 1. So 3x minus 1 equals 2y. And then I'm going to divide by 2. Now again, let's try to write it in this format. So 3x over 2 minus 1 over 2. And then we're just going to use our proper function notation. So the inverse of f of x equals 3 over 2x minus a half. Okay. Last problem. Y equals x plus 7 squared. So take your x and y, and you split them. You got x equals y plus 7 squared. All right, now we want to undo the square. So remember back a couple chapters ago, to undo a square root, you would square it. So here we have square. The opposite function would be or the inverse operation would be to take the square root. So these cancel. Now when I say this, I need to say plus or minus square root of x. And then the square root and the square would cancel. So just make sure you put plus or minus here. And then I need to subtract 7. So I got y equals, and then usually you put your negative 7 first, and then plus or minus root x. So here's my final answer. Inverse of f of x equals negative 7 plus or minus square root of x. You could also say inverse of f of x equals plus or minus root x minus 7. So that would not be wrong. That's just another option.